for this vodcast. Please have pages 15, 16, and 17 in front of you. Proceeding on with our functional groups, we're going to take a look at the alcohols today. Functional group, you're going to find an OH attached to a location of where a hydrogen atom used to be on our organic compound. So you may have R representing the rest of the atom, the rest of the compound itself, and you're going to have an OH, alcohol, branched off of one of the carbons. The example that's provided for you is 1-propanol. You can see the OH is branched off one of the terminal carbons at the very end. So let's go ahead. Let's jump ahead to page number 15. Let's get started with the alcohols. All right. Alcohols are going to be one or more hydrogen atoms. One or more hydrogen atoms on a hydrocarbon is replaced with an OH. It's called a hydroxyl group. All right? Don't get it confused with a hydroxides. This is going to be called a hydroxyl group. We're going to have E ending in the hydrocarbon, right? Where you find that is going to be replaced with an OL, which is going to represent an alcohols and its particular location. Same rules as naming halogens like we did in the previous podcast, except now you must state the location of the hydroxyl, the OH group, along the carbon chain. And once again, we're going to go with the lowest number location. The alcohols are going to be covalent molecules. They are not bases. They're not ionic. They're going to be a non-electrolytic. They do not produce electricity. Going to be considered polar, and certainly are going to be soluble, will dissolve within water. A note of caution, organic acids also have the OH within their functional group. We'll talk about the organic acids in a future podcast. Okay, let's take a look at our first example that's provided for us. All right, we have 1-propanol. All right, the OL right there tells us that we are dealing with an alcohol. So within this chain, we need to have an OH group. All right, so first thing first, let's get our longest possible parent chain. Since we're dealing with prop, we know we're going to have 3 carbons. Doesn't matter where we put the alcohol group, whether it's on this carbon here or this carbon here, it's still going to represent the first carbon. And simply, like the name says, 1-propanol. The OL, once again, represents that we're dealing with an alcohol. All right, now over here, we have a structure that's already developed for us. Let's take a look and count up the longest possible carbon chain. There are 4 carbons, so we know we're going to be dealing with a bute of some sorts. Here's our OH group, which represents we're dealing with an alcohol. And if we number with the lowest number location of the carbon atom, we are representing in the second position the hydroxyl group. So we have 2-butanol. All right, the OL once again indicates that we're dealing with an alcohol at position 2. Now on page 16, we're going to split this up into 3 different types of alcohols. We're going to talk about primary alcohols, secondary alcohols, and tertiary alcohols. All right. With a primary alcohol, basically what we're telling you is that the OH is located on a terminal carbon, so at an end position. It's attached to one other carbon within the chain. So the example we have for you is 1-pentanol. So if we start with the pent portion, we know that we're going to be dealing with 5 carbons. And the OL right here tells us we're dealing with an alcohol, and the 1 tells us that we are dealing with an alcohol, a primary alcohol. So the OH is going to be attached to one of the 2 ends, either here or here, because of the position 1. And then everything else is going to have hydrogen atoms attached to the carbon. All right. So as long as the OH is attached to either end, you're dealing with a primary alcohol. Now a secondary alcohol, the OH is going to be attached to a carbon that is attached to an interior non-terminal carbon. 2 other carbons within the chain. All right, so here's the group that's given to us. All right, remember, these locations right here represent where a carbon atom is located. All right, we want to make sure we have the lowest number of carbon represented here where our branch is going to be. So we're going to number in this direction here as opposed to the other direction, which would give us a higher location of where the hydroxyl group is going to be found. So for this, we've got 1, 2, we've got 2 is the location of where the OH is, our hydroxyl. And if we count up the number of carbons that are present, we're dealing with a hexane group. But in order to show that we're dealing with an alcohol instead, we've got 2 hexanol. Right? The OH is attached to an interior as opposed to a terminal location. The next one, tertiary alcohol. The OH, in this case, is going to be attached to the carbon, which is attached to 3 other carbon atoms. All right, since we're looking at prop, we know our main parent chain is going to be a 3-carbon chain. Looks like we have another branch in here, a methyl group found at the 2nd position. Let's go ahead and get that in there. There's CH3. All right, also located at the 2nd position is going to be our hydroxyl group. So the OH is going to be attached there as well. All right, and everything else is going to be filled in with carbon. The hydrogen atoms attached to the carbon. So 2-methyl. Switch this up. Number these. 2-methyl, 2-propyl, propanol. Okay? And then to finish up this vodcast, we're now going to take a look at dihydroxy alcohols. This is going to be an alcohol that has 2 OH groups attached within it. All right, so we're looking at 1,2-ethane diol. The di right here represents that we have 2 OH groups, and the OL obviously represents that we're dealing with an alcohol. Okay, so here goes its structure. Now the ethane means that we only have a 2-carbon chain. The 1,2 represents that, okay, we have a 2-carbon chain, but at each of the carbons, you're going to find a hydroxy. Right? Hence the reason we have 2 of them. 1, 2, position 1, position 2, ethane diol. Right? And everything else is going to be attached to the hydrogen. Okay, so we're looking at 1, 2, 1, 2. Ethane is the length of our chain. Di meaning 2 alcohols. And then the last piece of information here is dealing with a trihydroxy alcohol. This is going to be an alcohol that has 3 OHs coming off the carbon chain. Right? Tri, representing 3 hydroxy alcohol. All right, here we go. Let's get our main chain down. There's your propane. So it's got 3 carbon atom chain. We're dealing with 3 different hydroxys, hence tri. OL, once again, is the alcohol portion. We're going to have an OH, hydroxy 1, hydroxy 2, hydroxy 3, 1 off of each carbon, and then obviously everything else is going to be a hydrogen atom attached to the carbon to complete its octet.